Our lesson today is to be able to subtract integers. To subtract an integer, we add its opposite. We use what's called the additive inverse. So if we're taking a look at this first example here, if we want to subtract 3 and 4, we add the integer's opposite, and by adding the opposite, we now have an addition problem. What do I mean? Well, right now we have a subtraction problem. We want to take 4 away from 3. But we want to change every subtraction problem to an addition problem by using the additive inverse. So what we do is we change the subtraction to an addition, and we change the sign of the number that followed that subtraction sign. So now, instead of a subtraction problem, we now have an integer addition problem. 3 plus negative 4. And then we simply use the rules for addition. If we have a positive 3 and we add a negative 4, right, that sum is going to be negative 1. And that's essentially the process. We want to use the additive inverse, we want to add the opposite, and that means we change the subtraction sign to an addition sign, and then we change the sign of the number that follows. Alright, let's try some examples. Alright, we want to take 12 away from 3. So it's written as 3 minus 12. We want to use the additive inverse, so I want to add the opposite. The subtraction sign we change to an addition sign, and then we have to change the sign of the number that followed that subtraction sign. So now we have 3 plus negative 12. 3 plus negative 12. We use our rules for adding integers now because we now have an addition problem. 3 plus negative 12 is going to be negative 9. Next example. We have negative 8 take away negative 13. We want to use the additive inverse, so I want to change the subtraction sign to addition sign, change the sign of the number that follows. Notice in our first two examples we never touch that first integer. That first integer never changes. But when we use the additive inverse, we add the opposite of the integer that followed. We now use the rules for addition of integers, because we have an addition problem now instead of a subtraction problem. Negative 8 and positive 13. We subtract. That's going to give us 5. Take the sign of the higher absolute value number as positive. So that's going to be positive 5. Right? So we spent all that time, a few days, adding integers. We wanted to get those rules for adding integers. We wanted to learn them very, very well. And now we simply have one step to change every subtraction problem to an addition problem. What's the one step? It's the additive inverse. We add the opposite. We change the subtraction sign to an addition sign, change the sign of the number that follows to its opposite. Now we have 5 plus positive 4. That's going to be 9. Alright, so let's try some examples here. We have 8 minus 3. Well, I want to change that subtraction problem to an addition problem by using the additive inverse, so I'm going to add the opposite. Now I have positive 8 and negative 3. Right, that's going to be 5. 9 minus 17. I add the opposite. Using the additive inverse, this problem becomes 9 plus negative 17. I use the rules for addition of integers. Now I'm adding opposites here, so I have to subtract the 9 from the 17. That's going to give me 8. I have more negative than I do positive. It's going to be negative 8. Our next example, negative 3 minus 3. I change the subtraction sign to an addition sign, change the sign of the number that follows. Notice we never touch that first integer, right? If you look at these first three examples, that first integer never changes. It's only the subtraction sign becomes an addition sign, and we change the sign of the number that followed that subtraction sign to its opposite. Here, that number was positive, so it became negative. Alright, so now we have negative 3 plus negative 3. It's going to be negative 6. Alright, example 4, negative 14 minus 9. Add the opposite. Now we're adding two negative numbers. We add their absolute values. That's going to be 23. Keep the sign the same. It's going to be negative 23. Problem 5, 9 minus negative 8. We want to add its opposite. So that becomes 9 plus 8. That's 17. Problem 6, We have negative 12 minus negative 12. We add its opposite. So this becomes negative 12 plus 12. I'm adding opposites here. I'm adding a negative 12 and a positive 12. So we subtract. That's going to be 0. All right, let's take a look at some more examples. I have 8 minus 13. I want to use the additive inverse. So I want to add the opposite here and change the subtraction problem to an addition problem. Change the subtraction sign to an addition sign. Change the sign of the number that follows to its opposite. Now I have 8 and negative 13. I use my rules for addition. My rules for addition say we subtract the absolute values. That's going to be 5, and we have more negative than positive. That's going to be negative 5. All right. Next example. We change the subtraction to addition. Change the sign of the number that follows. I now use my rules for addition. Negative 10 plus negative 7. That's negative 17. Some more examples, right? Just to practice, because the more we do, hopefully the better we get. 6 minus 12. I add the opposite. That becomes 6 plus negative 12. It's going to be 6 and negative 6. Why is it negative 6? Because of when I use my rules for addition, I'm adding a negative and a positive here. So when we're adding opposites, we subtract and we take the sign of the higher absolute value number. It's going to be negative. Example B. We start off with a subtraction problem, but when we use the additive inverse, we add its opposite, right? It's 2 steps. Change the subtraction to addition, change the sign of the number that follows to its opposite, and then we use our rules for addition. Negative 20 and negative 15, it's going to be negative 35. Negative 22, take away 26. We add its opposite. Negative 22 and negative 26, it's going to be negative 48. Some more examples. 1 minus negative 2. Right? I want to change the subtraction problem to an addition problem using the additive inverse. So we add the opposite. This becomes 1 plus 2. That's 3. 10 take away negative 7. I want to add the opposite. This becomes negative 10 plus positive 7. That's going to be negative 3. All right. These next 3 examples. I have 4 take away negative 12. It's a subtraction problem. I have to recognize it's a subtraction problem, so I have to use the additive inverse. So I add the opposite, which means I change the subtraction sign to an addition sign, change the sign of the number that follows to its opposite. We now have 4 plus 12. That's going to be 16. Negative 15, take away negative 5. When we use the additive inverse, we add the opposite, change the subtraction to addition, change the sign of the number that follows to its opposite. We now have negative 15 plus positive 5. I subtract their absolute values because they're opposites. There's more negatives than positives, so that's going to be negative 10. 18 take away negative 6. I want to use the additive inverse, so we have to change that subtraction sign to an addition sign. I want to change the sign of the number that follows to its opposite. So we have 18 plus 6. That's going to be 24. Okay. Now, if we're subtracting more than just 2 integers, we have to use our order of operations, which says we do addition and subtraction from left to right. So I start with the first subtraction I see. This is negative 7, take away negative 12. So I use the additive inverse. I add the opposite. Change the subtraction to addition, change the sign of the number that follows. So I do these first 2 integers. Negative 7 plus 12, it's going to be positive 5. But I recopy this minus 14. Then I do that problem next. 5 take away 14. We use the additive inverse, so we add the opposite. That's going to be 5 and negative 14. That's going to be 9. When we subtract 14 and 5, and it's going to be negative 9 because there's more negative than there are positive. All right? Well, let's start with number 7. I'll do that here. Problem 7, I'm going to recopy it. That's going to be negative 9 minus 16 minus 8. Start with the first two integers. Negative 9 take away 16. We use the additive inverse, so we add the opposite here. This is now negative 9 plus negative 16. It's going to be negative 25. But we recopy the minus 8. Once again, I want to use the additive inverse because I see subtraction. So we add the opposite, change the subtraction to addition, change the sign of the number that follows. We have negative 25 plus negative 8. It's going to be negative 33 for problem 7. All right. Problem 8. Copy here. I'll just do it here. Problem 8, we have negative 4 minus 20 minus 9. We start with the first two integers. I see the subtraction sign, so we have to use the additive inverse. Change the subtraction to addition, change the sign of the number that follows to its opposite. So we have negative 4 and negative 20. That's negative 24. Then I still have that minus 9. I use the additive inverse, so we change the subtraction to addition, change the sign of the number that follows. Right, that is also going to be negative 33. Question 9. Question 9 says we have 0 minus 9 minus the negative 5. I start with the first two integers, 0 minus 9. When we add its opposite, that's 0 plus negative 9. So it's going to be negative 9, but then we still have the minus negative 5. Right, I want to use my additive inverse, so we change the subtraction to addition, change the sign of the number that follows to its opposite. You have negative 9 plus positive 5. That's going to be negative 4. All right. Okay, let's try question number 10. Right, question 10, we have negative 8. That's minus negative 6 minus 0. Start with the first two integers. I see subtraction, so I use the additive inverse. Right? Change the subtraction sign to an addition sign. Change the sign of the number that follows to its opposite. Negative 8 and 6. That's going to be negative 2. But then we still have minus 0. Right? Add the opposite. Right? If we have negative 2 and we add 0, right, that's still going to be negative 2. That's our answer. Right? Problem 11. Problem 11, you have 15 minus negative 20, and then we're subtracting another 20. Start with the first two integers. Right? I see its subtraction, so I add the opposite. 15 plus 20, it's going to be 35, but then we still have the minus 20. 35 minus 20 we know is 15, but I'm still going to use the additive inverse, so we add the opposite. 35 and negative 20 is still going to be 15. All right. In our last example here, problem 12. Problem 12, we have negative 14 minus 9 minus 36. Start with the first two integers. I see the subtraction. When I see the subtraction, I want to use the additive inverse, so I add its opposite. Negative 14 plus negative 9, right, that's negative 23. Then I still got to take 36 away from that. Add its opposite, negative 23 plus negative 36. It's going to be negative 59. All right, we continue. We want to be able to evaluate expressions using integers now. So when we're given an expression, evaluate x minus y if x is negative 6 and y is negative 5. First step, we want to replace x with negative 6. So I rewrite the expression after I substitute negative 6 for x and then negative 5 for y. So there's your first step. I see it's a subtraction problem, so I use the additive inverse. We add the opposite. Negative 6 plus 5, it's going to be negative 1. All right. Problem 6, m minus n. If m is negative 15, and n is 8. I'm going to replace m with negative 15. Then that's going to be minus 8. I use the additive inverse, so now I have negative 15 and negative 8. That's going to be negative 23. Right? A few more examples down here. B take away 10, B is going to be negative 8. So I use parentheses to show that substitution step. We're replacing B with negative 8, and then we have minus 10. Negative 8, take away 10. We use the additive inverse, we add the opposite. Negative 8, negative 10. It's going to be negative 18. A minus B. A is 5. B is negative 8. So we have negative 5 take away negative 8. We add its opposite. 5 plus positive 8. That's going to be 13. Alright, C minus A. C is negative 9. So I replace C with negative 9. I'm going to replace A with 5, right? Because we're told A is equal to 5. Use the additive inverse because I see subtraction. Negative 9 plus negative 5. That's going to be negative 14. Okay. Here we're given more of a word problem type question. Which continent has the greater range of elevations? To look for range, we need the difference between two numbers. So to find the range of the in North America, we have to take negative 86 away from 6,198, and that's going to look like this, right? But we use that additive inverse, so we'd have to add, right, the opposite here, and that becomes 6,198 plus 86. That's where we get 6,284. If we're looking at the continent of Africa, still need to find the difference between these two numbers. Right? I set up a subtraction problem, but once again we have to use the additive inverse. This problem becomes 5,895 plus 155. That's going to give you 60,050. Alright? Let's try this example here. The highest elevation in Mexico is 5,700 meters on Pico de Orizaba, or Orizaba. The lowest elevation in Mexico is negative 10 meters in Laguna Salada. Find the range of elevations in Mexico. So we have to take 5,700 and take away negative 10. Alright? I want to change the subtraction to addition. Change the sign of the number that follows to its opposite. Remember, that's called using the additive inverse when we add its opposite. So this becomes 5,700 plus 10. So that's 5,710. Our last example, or a couple of examples here. The temperatures on the moon vary from negative 173 degrees to 127. Find the difference between the maximum and minimum temperatures. So we have to subtract the lower temperature from the higher temperature. So we would set it up this way. 127 minus negative 173. I want to change the subtraction problem to addition problem by using the additive inverse. So we add its opposite. 127 plus 173, that's going to be 300 would be your difference. And then the last example here, we have Brenda had a balance of negative $52 in her account. The bank charged her a fee of $10 for having a negative balance. What's her new balance? We have to start with the negative 52 and then we take away another $10 in fees. We add the opposite, negative 52 plus negative 10, right? That's going to be negative 62. Alright, so we did a lot of examples where we are subtracting integers. Remember, when we subtract integers, we use the additive inverse. The additive inverse involves two steps. We change the subtraction sign to an addition sign, change the sign of the number that follows to its opposite. Remember, we never touch that first integer. Alright, hopefully that's been helpful, and we will see you soon.